Hello listeners, in this session we are going to discuss basic economic order quantity model, better known as a EOQ model. This is a part of deterministic inventory control model. In any inventory related decision, it is very important that what is the quantity that should be ordered and when to order. So in this video or in these sessions, we are going to cover the importance of inventory control in construction industry, economic order quantity concept, assumptions of basic EOQ model, how to determine EOQ, and how to determine reorder point. So the major focus in this session will be understanding EOQ and its applications. In any industry, whether it is a construction industry, manufacturing, steel industry, there are three basic inventory policy decisions which are taken. One is how much stock to order or reorder. We call it as a reorder quantity. When to order means reorder point. We also call it a reorder level. Third is when to review. When to review means what inventory system you should follow, whether it should be a periodic one or it should be a continuous review system. It is better known as a fixed order quantity system. So the main objective behind any inventory policy decision is to minimize total inventory related cost. In the earlier session, we have demonstrated what are the inventory related costs and how these costs vary with each other's cost and what are the relationship existing across all different related costs, and also we learned what are the classification technique used in inventory control system. Now, what is economic order quantity? Before understanding the concept of EOQ, we should understand first that inventory related costs are basically into four categories. One is cost of an item or purchase cost, ordering cost, carrying cost, stock out cost or shortage cost. And if you would like to calculate what is the total annual relevant cost pertaining to inventory, it is total annual purchase cost plus annual ordering cost plus annual carrying cost plus stock out cost. Further, you also know that carrying cost is inversely related to ordering cost. What does it mean? That any reduction in carrying cost will lead to increase in the ordering cost and vice versa. Or it means if you increase the frequency of ordering, your carrying cost definitely will decrease, but ordering cost will increase. If you decrease the placement of the orders or frequency of order, your inventory carrying cost will increase. Now, if you see that relationship is inversely proportional to each other, so the question is whether you should demand or place the large quantity or small quantity. Okay, so in small quantity your ordering cost will be higher, in large quantity when you are placing it or your carrying cost will be higher. So there is a question how much quantity you should order so that total inventory cost is minimum. This is what the EOQ is. So this is the quantity or size of order at which overall cost related to inventory is minimum. And we are assumed that annual demand is fixed or known with the certainty. Let us understand the concept using graph. The question of identifying economic order quantity arises because of the two costs are directly, or we can say inversely proportional to each other. So if you look at the ordering cost, when you increase the size of order, your ordering cost decreases, but your carrying cost increases. So the quantity at which your total cost related to inventory is minimum is known as a EOQ. So you can see in the graph that the violet color line, it shows that the trends in the total cost when you increase the order quantity or when you decrease the order quantity. So the bottom point of the total cost curve represent the minimum total cost, and the vertical line that is represented on horizontal, that is x-axis, represent the Q optimum. This is also known as a economic order quantity. Now, when we define EOQ as the size of order, the quantity at which total inventory cost is minimum, so it is also important that whatever the terminologies which are used in EOQ calculation should be known clearly. These are also known as a quantity standards. So first is a maximum quantity concept or inventory. This term is applied to designate the upper limit of inventory and represents the largest quantity which should generally be kept in stores. The second is the minimum quantity, the lower limit of the inventory, and represents a reserve or margin of safety to be used in case of emergency or uncertainty. The purpose should be to hold enough but not excessive stock of materials so as to avoid running of stock out of stock, or you create a buffer stock which may be utilized if the materials falls below a minimum level. Other aspect is ordering point or the reorder point or reorder level. It is a quantity required to ensure that there is an adequate material for the interval between the placement of an order and delivery. So this level should be identified after which you place an order to the supplier. The next is a lead time. So lead time is the time taken from the time the requisition for an item which is raised till the supplies are received, inspected, and then taken into the stock. So lead time involves the time taken by the following activities like inquiries, quotations, scrutiny, negotiations, and approval, followed by import formality if in case of the items are being imported, placing an order, time taken by suppliers for making the goods ready, transportation, receipt of goods, inspection, and finally the taking the material into the stocks. So the lead time is nothing but the time gap between the ordering for the item and receiving the item. Next is the reserve or safety or buffer stock. In order to safeguard production process against uncertainty in the consumption rate and lead time, an extra stock is maintained along which is called a safety stock. When we say uncertainty, the management always faces uncertainty from two sides. One is from the customer side or demand side, and the second is from supplier side. So the demand side is basically related to the consumption pattern. Consumption rate may varies because of the changes or preference in the demand by the customers, and the supply side uncertainty is there because of the uncertainty towards either transportation or production schedule and all. So the lead times are basically because of the suppliers from the supplier side. The factors which are to be considered for the purpose are variation in the consumption expected during the lead time and variation in the lead time expected during considering the prevailing market conditions for that item. The safety stock should then be sufficient to last for the period difference between maximum and a normal lead time. So it is always in addition the safety stock to be calculated. So in setting maximum and minimum and ordering quantity, each item should be considered separately in the terms of following factors. One, what is the economic quantity of each purchase order? What is the amount or the money that is locked up as a capital? The time required to receive the goods and after requisition, the probable depreciation and obsolescence, and the fourth is the rate of demand. So, in order to calculate EOQ, or when you work with the EOQ model, economic order quantity model, it is important to understand the various underlying assumptions. So, first is demand is known with the certainty and the constant over the time. The consumption of items is uniform, means the rate of consumption over the period of time will remain constant. It will not vary too much. The third is no shortages are allowed, means you do not consider any situation of the shortage or stock out issue. Fourth is lead time for the receipt of orders, which should be a constant. Means there should not be any variations. Even if there is variation, that very minimum. The item is replenished in lots or batches, either by purchasing or by manufacturing. It means the EOQ deals with a more or less cycle stock. Next is the order quantity received. It is only at once. It is not that you are placing again the order and the items are arriving in this. That is another model. So when we want to calculate EOQ, there are four things, the four terms which are very important to understand in calculation. One is the cost of placing an order, that is CO. D is the annual demand. C is annual per unit carrying cost, and Q is the order quantity. Somewhere you will find Q star or Q dash and all. So it depends upon what kind of the symbol you are using it. So annual ordering cost is calculated how? So it is nothing but the number of orders you are multiplying with the cost of ordering. That has been discussed in earlier session also. So CO stands for the cost of ordering multiplied by D upon Q. D is nothing but annual demand upon Q is the quantity order. So D upon Q represents also the number of orders. So annual carrying cost is CC multiplied Q upon 2. How the divided by 2 is coming? So annual carrying cost is nothing but the annual per unit carrying cost multiplied by the average inventory held. So average inventory, how do you calculate? It is 0 plus or opening stock plus closing stock divided by 2. So CC multiplied Q upon 2. So total cost in the simple EOQ model is basically the addition of annual ordering cost plus annual carrying cost. However, in calculation of total inventory related cost, you add the cost of an item or purchase cost when there is a difference in the price being offered by the supplier in case of the quantity discount. If the quantity discount is not offered, so for EOQ calculation is not mandatory. But for in order to calculate total inventory cost, it is important to incorporate. Now, how EOQ is determined? There is a process, the formula, basically how to find the EOQ formula. There is a process involved. So you calculate total cost is equal to annual carrying cost plus the your total ordering cost, because you want this you want the cost should be inventory cost could be minimum. So you differentiate total cost with respect to the quantity orders. After derivations, you find Q optimal or economic order quantity as a finally square root of 2 multiplied by ordering cost multiplied by annual demand divided by carrying cost. So let us take the example to understand how EOQ is calculated. A construction company uses rupees 20,000 worth of an item during the year. The ordering cost was estimated as rupees 50 per order and carrying cost were estimated as 12.5% of the average inventory held or average inventory value. So you need to calculate what is the optimal order size. The second, what is the number of orders per year. Third, the time period per order. And fourth, what is the total inventory related cost. So here you need to know what is the annual carrying cost. You need to know what is the ordering cost, total ordering cost. Based on that, you can calculate what is the total inventory related cost. So here the annual demand is 20,000 and carrying cost is rupees 50. Ordering carrying cost is 12.5% of the average inventory value per unit. CO is that is rupees 50. Now how you will calculate the quantity orders? So total. So in order to calculate Q, you have got a formula, that is square root of 2 multiplied by annual demand multiplied by the ordering cost divided by inventory held or average inventory held, that is representing 12.5%, which comes out as 0.125. So you get the quantity order as 4,000. The cycle period you can calculate by optimal order quantity divided by annual demand. And finally, you can get the cycle time for ordering is 73 days. The number of orders you can find the values, and by 1 upon 3, that is 365 upon the 73, that is 5. Accordingly, you can calculate total inventory related cost. Now, when you would like to calculate reorder point, so level of inventory at which new order is placed is known as a reorder point or reorder level. So, R is equal to D multiplied by L, where R is the reorder point, D is the demand date per period, and L is the lead time. So, if delivery is instantaneous, so reorder point may be 0. But if there is a lead time when you are placing an order till you receive the items, so you need to calculate reorder point. So, in the case of certainty, when lead time is fixed, so this is the formula you can use for calculating the reorder point. So, let us take the example. An item is used at uniform rate of 50,000 units per year. No shortage is allowed and delivery is at an infinite rate. The ordering, receiving and hauling cost is rupees 13 per order, while inspection cost is rupees 12 per order. Interest cost rupees 0.056 and deterioration and obsolescence cost is rupees 0.004 respectively per year for each item actually held in the inventory, plus 0.02 per year per unit based on the maximum number of units in inventory. Now you have to calculate the EOQ. If the lead time is 20 days, find the reorder level. So it's simple. Here you have got ordering cost as a 13 plus 12, that is rupees 25 per order. Storage cost is based on the actual inventory. It has already been given, that is 0.056 plus 0.004, which is coming out as a 0.060. So, storage cost based on maximum inventory you can find, it is given 0.02 per unit per year. Demand is given 50,000 units per year. So, total variable cost you can calculate by your carrying cost and ordering cost, and you can find finally the value as the economic order quantity as 5,000 units. Now, reorder level you can calculate the what is the lead time and what is the annual demand or demand. That is, you can calculate lead time and multiply D, that is 20 multiplied 50,000 upon 365, which is coming out as a 2,740 units. It means that reorder level is representing the inventory level at which you should place another order. So, in this lesson you learnt about not only the inventory related cost and how to calculate the economic order quantity. You know that out of total cost of construction project, about 65% to 70% cost is the cost of materials used. Therefore, control over the cost of material used is required for reducing the cost of construction. The cost of materials can be controlled by controlling the inventory of the tools, equipment and materials. So, how much material should be ordered, and then how to calculate EOQ and then reorder point and lead time will definitely help in minimizing the total inventory related cost. Thank you.